Welcome back, everyone. So in the previous video, we learned about the gold foil experiment by Ernest Rutherford that determined that an atom is comprised of three subatomic particles. The proton and the neutron, those two subatomic particles are located in the center of the atom in a dense core called the nucleus. And outside of the nucleus are the atomic particles called the electron. J.J. Thomson first discovered those in the late 1800s, but these electrons are outside of the nucleus, just kind of hanging around. So now in subsequent chapters, we're going to talk in more detail about where an electron is in an atom. But for right now, you should just know that they're outside of the nucleus and that the majority of the atom is empty space. So you should know those three subatomic particles, their location of the atom. You should also know the charge associated with each subatomic particle. Electrons are negatively charged, neutrons have no charge, and protons are positively charged. We're going to talk a lot more about electrons in the course with regards to where they are in an atom and what happens when atoms share or donate electrons to form bonds. But what we're going to focus on now is the subatomic particle called the proton, because it's the proton that distinguishes atoms from one element from atoms in another element. And what that means is that elements are defined by their numbers of protons. Protons, protons, protons. So if an atom, the particular element, had a different number of protons, then it would be a different element. And we're going to see that come into play also when we start looking at the periodic table. But elements are defined by their number of protons. If an element has a different number of protons than another element, then they are not the same element. So for example, helium has 2 protons. Let's say I was to find another element and determine it has 13 protons. Can't be helium because they have different numbers of protons. So elements are defined by their numbers of protons. It's an important fact to know, and we will revisit that when we talk about the modern periodic table. But let's talk about how did the periodic table, that beautiful chart that shows all the different elements, natural and man-made, that we know so far, how did that come into play? So actually there are lots of scientists that have helped construct that periodic table, but the one that is the most infamous in constructing what we now see as the periodic table is Dmitry Mendeleev. Russian scientist. He was the first scientist really to organize elements according to their mass and their chemical properties. And so he was able to organize these elements in not just one long big list, but in a way that scientists could use to make predictions about how some elements will behave and how others will behave. So this slide right here is the very first periodic table that Dmitry penned based off of the knowledge that he had and other scientists had of elements. We're going to talk about the parts of a periodic table later, but what I want you to take away from this now is this quote from one of my favorite books, which is written about the history of science, specifically the history of chemistry, The Disappearing Spoon. But the author says that for most elements, geography is destiny. What that means is that elements that are in the same group, in the same column of a periodic table, have similar properties and similar reactivities. Dmitry recognized that with his first periodic table. He recognized it so much so that he even predicted where certain elements would lie based upon reactivities. We see that time and time again with the modern periodic table as well, which is that elements that are in the same column, which are groups, have similar reactivities and properties. Their geography is destiny. So this is Dimitri's periodic table. I have some other fun periodic tables here for you just to look at. So I'm sure you have seen a periodic table before taking this course, maybe from a general physical sciences class. These are just some that I thought were kind of fun. We went to Korea a few years ago. So of course, you know, when we went on lots of different tours, I had to find a periodic table that's in Korean. You can have periodic tables in different languages. You can have yummy periodic tables. The chocolate one is my favorite. And you can have periodic tables that have different themes to them. I thought this Disney theme was quite cute. Now, obviously, the periodic table that you will be able to use for quizzes and exams is not going to be any of these. These wouldn't be very helpful to you because, well, at least in the case with the Disney periodic table, NE on the periodic table that's supposed to be neon. We'll talk about names and symbols in the next video, but I bet you can guess on the Disney periodic table, NE does not stand for neon, it stands for Nemo. And I believe H on that stands for Hercules. So these periodic tables would not be very useful to you in this course. They're just kind of fun to take a look at. The periodic table that you guys will be using in this course is going to be very similar to the one that is in your textbook, and I have a copy of right here. In the next and in subsequent videos, we're going to start to deconstruct this periodic table and determine information that you can glean from it for particular elements.